Good morning. Today we're going to talk about why you need to flip the inequality sign when you multiply or divide by a negative. I have noticed that sometimes students remember to flip this sign if they divide by a negative, but this is also true if you multiply by a negative. So let's look at why this works. First, let's talk about multiplying by positive numbers. Let's say you just pick two numbers off number line, such as -4 and 2. We know that -4 is less than 2. Let's see what happens to this relationship of less than if we multiply both numbers by some integer value, for example, a +2. So if I multiply both numbers by +2, I get -8 and 4. And -8 is still less than 4. So multiplying by a positive didn't change the inequality relationship between our numbers. Now let's examine dividing by a positive. Let's say we use again -4 and +2. If I divide by a positive number, let's say a 2, what's the relationship between the resulting numbers? Well, -4 divided by 2 is -2. And the relationship doesn't change. -2 is less than 1. The result of dividing by 2 and 2. Okay, so now we're just going to do a couple of inequalities just to work with this. Solving inequalities is just like solving equations unless you multiply or divide by the negative. Then you have to flip this sign. So let's examine the first inequality here. It's x divided by 4. In order to isolate what the x represents, let's use inverse operations. If I multiply both sides by 4, I know that x is representing any number less than 44. Now let's look at how to solve this second inequality. We know from the very beginning that the inequality sign will not change because there is no negative with the x. So we've got 2/3 times x is less than 14. One way to solve using inverses would be to multiply by the reciprocal. This is probably the easiest way. So on the left-hand side, when you multiply reciprocals, you get 1. The new coefficient of x is 1. Our inequality sign, we're going to bring that down because we have not used negatives at all. And then 14 times 3, we've got 42 over 2, which we can reduce. And in Algebra 2, we like to leave our answers in the improper form in general. But here, 42 actually will divide by 2, so our final answer is that the x represents any number less than 21. Now let's examine what happens if we multiply by negative. Let's use our same numbers, -4 and 2. This time, let's just multiply by -2. -4 times -2 is +8. And 2 times -2 is -4. So is this true? If I bring down the inequality sign, is 8 less than -4? No, not at all. In fact, the relationship has reversed. 8 is actually greater than -4. So we can see that when you multiply by a negative, in this case we had to flip this sign, and this would be true at all times. Let's examine an instance of dividing by a negative, again starting with our same numbers. -4 is less than 2. Well, let's say I divide by -1. The resulting numbers are +4 and -2. So wait, 4 is greater than -2. So dividing by a negative means the inequality relationship changes fundamentally. Now here you can see I just used a -1. You can see that essentially what happens is that the signs change in the numbers And so this is always going to happen. You're always going to have to reverse your inequality sign when you multiply or divide by a negative. So let's examine a couple cases where we're going to have to do this. In the first inequality, remember our goal is to solve for x. We're going to use the basic principles of solving an equation with just this one extra task that we have to do, changing the sign. So we're going to simplify if we can, do to one side of our inequality what we do to the other, and make sure that we use inverse operations to isolate the variable. So first I'll subtract 30 from both sides and bring down the simplified inequality. Then I'm going to divide both sides by -6. And when I do this, since the divisor is negative, I've got to flip the inequality sign as we saw from our previous examples. So to make this inequality true, we could use any number greater than or equal to 5. Let's look at the next equation. You can think of this a couple different ways. You could think of that as -1/2 times x plus 20. Or you could think of that as x over -2. The net result solving the inequality will be the same. So we're going to use our basic steps, our inverse operations, to try to isolate our variable. And here, again, I can think of this a couple different ways. I could think of this as -1/2 x. That would be fine. To cancel out the fraction, I would need to multiply by the negative reciprocal, 2 over 1, which is essentially just multiplying by -2. And so now we can see that the value of x would be any number greater than or equal to +32. Today we've examined why you need to multiply or divide, or why you need to reverse the inequality sign if you multiply or divide by a negative, and also some examples of times when you would choose to reverse the sign or